PLCs come in different sizes and configurations. Smaller systems are more limited, with fewer options and smaller quantities of inputs and outputs, I/O, available. These micro PLCs are suited to smaller machines. Larger modular systems are available with add-ons that can scale up to the largest of projects. The real takeaway here is that PLCs come in many different sizes, but in each of these systems there are common components and concepts. And we will talk about some of the common things now. A rack or base unit, and this applies to modular systems only. Also, sometimes it's called a backplane or a chassis. For modular systems, there needs to be a base to mount the components, like the power supply, somewhere to plug in modules like the CPU, input modules, output modules, and other add-ons. What modules are selected are determined by the system designer, and that's really the idea of a modular system, is that different modules can be selected to create a configuration that suits your needs. All those modules are held together by this base. Every PLC system has some kind of power supply. This could be external to the PLC. It might be built into one of the smaller micro units with their all-in-one unit design, or it might mount on a rack on a modular system. They're available with different input voltages, and that depends on what source voltage you want to connect to. Available input voltages include 24 volts DC, 120 volts AC, 240 volts AC, whatever matches your line voltage. The output voltage is the correct level to power the PLC components. This will power up the CPU, input modules, output modules, other modules in the system. It is designed to deliver clean power to the delicate electronics. It is filtered and relatively low current. It is not designed to power the field devices. The example in the diagram shows a power supply with a 120 volt AC input, and it's converting that to the DC voltage required by the PLC. CPU is the central processing unit. That's the unit that houses the processor and memory that is the brain of the system. The diagram shows a modular system with a power supply to the left and a CPU is plugged into the base unit. Typically, programs and data are stored in random access memory, that is RAM. This includes the user program and the status of inputs and outputs. RAM is volatile, which means data will be lost when power is removed. A PLC with RAM memory will have a battery backup. That's why we mention this. It is important to know if your PLC has a battery. It's there for a reason. You do not want to lose precious data. More modern and upscale PLCs are equipped now with flash memory or SD cards to back up the user program. For those systems, usually no battery is required. The firmware and operating system are stored in non-volatile memory called read-only memory, or ROM. These files are critical to basic processor function. That is why they are read-only and not accessed by the user. If this data was to become corrupt, it can turn the CPU into a brick, and we don't want that to happen. To make firmware upgradable, some systems may have a special type of ROM known as electrically erasable programmable read-only memory, EEPROM. Firmware can be loaded using a process known as firmware flashing, where a specific procedure is followed to write a new firmware file. Firmware flashing is not for amateurs. If something goes wrong during the process, well, remember the part about corrupt data bricking the CPU. Some things you might see on a CPU module include LED lights, or maybe even a text display that show the processor status with indications for stop, run, or error status. Often there are communication ports like Ethernet or USB connectors. This is to connect the PLC to a programming device or other network devices. There may be even a switch to start the program or stop the program and reset the PLC. There are variations, but this is very typical. Now the input and output sections, or I/O sections. It is the field devices that connect the PLC to the real-world elements of a machine. Components in the field that are connected to inputs are things like switches, sensors, and relay contacts. Components in the field that are connected to outputs are devices like indicator lights, solenoids, or relay coils. That is not a complete list of field devices compatible with a PLC, but it's a good start. Termination points are required to connect the field devices to the PLC. On smaller systems, these terminals can be found on the body of the main unit. Modular systems will have dedicated modules for wiring I/O. The diagram shows a modular system where an input interface module and an output interface module have been inserted into the base unit. The input interface will convert the connected inputs into digital data for the processor. The output interface will convert digital data from the processor for the connected outputs.